Welcome, everyone. I'd like to thank you for coming today. I'm Craig Gresbrink. I'm a solutions architect at 24 Hour Fitness. I've been a solutions architect for about 6 years now. Before that, I was a PL SQL and Java developer for about 12 years. So I've been there 18 years. I'm sort of a lifer. And aside from this self-deprecating Dilbert architecture comic, every good presentation starts with a joke and ends early. So you guys are in control on how many questions if it ends early, but I'll do the joke. Since it's close to Halloween, who did the skeleton take to the dance? Nobody. Who is 24 Hour Fitness? We operate 400 clubs in 13 states. And we do, of course, the normal club stuff you would expect, gym subscriptions and workout facilities. We also do personal training and group exercise classes. Here's what we're going to talk about today. We're going to talk about how in-memory solutions have assisted with our SaaS integrations. But in particular, we're going to start off with our historical architecture and the limitations that that architecture had. Then we're going to jump into, like I said, how the in-memory solutions how we changed our architecture to assist with our integrations. And then we're going to talk about some issues we ran into and things we might do in the future now that we have an in-memory solution or in-memory solutions plural in place. And followed by Q&A, and I'm standing between you and the reception, so we'll make it quick. This was our historical architecture at 24 Hour Fitness. All of our apps basically these were custom applications we were building 6 to 8 years ago, if not longer. All of our applications had a user interface. We had a load balancer, and the key with the load balancer is that it was round robin, meaning it didn't keep track. It wasn't sticky session. It didn't keep track of which JVM you went to before the first time. And you can see how that may have caused us a problem. A member would come in and make a request, and they would come into a single JVM, and we would query the database, and we would capture that information and cache it into a JVM. The problem is that if a customer came back and the round robin load balancer sent them to the second JVM, we would end up having to query the database a second time. That problem only becomes worse as we scale horizontally with the JVMs. So essentially, we had more cache misses than we needed. Our first use case that we had a problem with was we have a customer service portal where you can log in and authenticate, and you can check your balance, and then you can decide if you want to make a payment. If you don't make a payment, you get a red screen, you can't get into the club. So what was happening was we would come into the UI, they would authenticate, we would get their balance. The biggest problem is they'd make a payment, but we don't write to the base tables in Oracle apps where we get their list of open invoices. We write to staging tables and we charge the credit card, and there's a batch process that takes anywhere from, it could take as much as up to 6 hours to get into the regular tables. So people were coming in to the UI, making a payment. Let's say they owed 100, get balance returned 100. They paid 100. We cached it in this JVM. We stored it in the staging tables, but the batch hadn't run. When they came back 2 hours later, the batch hadn't run, so we said, you owe $100. So what did we do? We solved it. We put some text on the UI that said, it may take as much as 24 hours for your payment to be processed. Nobody reads those UIs, nor should they have to. So we got duplicate payments, and our customer services group had to refund people. So it just really didn't match what the customer expected. So how are we going to solve this? Well, we're at the In-Memory Computing Summit. You probably have a guess. We brought in Hazelcast, a distributed cache mechanism, and it's pretty much the same flow, except for now when you come in and make a payment, we do the same thing. We write to the staging tables, but then we go ahead and we cache it in the same JVM like we did before, but now there's a distributed cache in place. So if you come back a second time 2 hours later and you hit this JVM, we're still going to query the base tables. We're going to say you owe 100, but we've cached that you paid 100 in this JVM, and this JVM's aware of it. So now we deduct your paid invoices from what our base tables at that point in time think are your open invoices, and we say you owe $0. Customer's happy because that's what they expect. We could have solved it. Our historical approach would have been to query the staging tables and detect the payment there. Obviously that's slower, and the other issue with that is 99% of the time, the person coming into this system to make a payment hasn't made a previous payment. So we're adding performance penalties to everybody just to solve that 1% or less who comes back 2 hours after they make a payment. So the in-memory dispute, the distributed cache is a much more elegant solution in terms of response times. So a theme I'll be making in this presentation is once you have an in-memory computing solution in place, you'll find that it solves a lot of other use cases. In our example, some of our customers, it was taking as much as 40 seconds to retrieve the amount that they owed us. And that's because those customers were loyal personal training customers, and they purchased many agreements with us over the course of 10 or more years. And that meant they had a lot of data in our Oracle Apps database and such that query was 40 seconds. In the past, we probably would have never solved it, but once we had the distributed cache in place, we changed things up a slight bit. We said, let's pre-cache or pre-fetch their balance due at the time they authenticate into the UI. So now you authenticate in the UI, we'll send an asynchronous request, and the JVM will query the base tables, get your balance due, and this system isn't just for payments. You could go in and see your club visits, you could look at your loyalty points, there's a lot of other features. So if they come to the make a payment screen, now the data's pre-cached, and we solve that problem as well. So we changed our architecture up a bit, and we decided, well, the first thing is I said that we were building a lot of custom applications in the past where we controlled everything from the UI to the database. Now we're implementing a lot of SaaS or vendor applications, and we're integrating with their APIs. And that's changed things quite a bit. So we brought in GridGain. Actually, we brought it in as Ignite, and then once we started utilizing it to an extent where we wanted support, we upgraded to GridGain. So if I say Ignite or GridGain, you guys probably know by now, they're pretty much synonymous. We started off with 4 JVMs or 4 GridGain nodes, and then as we added more data into the system, we scaled horizontally and added 2 more JVMs. And I suspect over time we're going to add more JVMs as we start caching more data. But basically, we made the data grid a first-class citizen in our architecture. So our first SaaS system comes into play. We were running PeopleSoft HR on-prem, and we decided to bring a SaaS HR system online. And naive Craig thought, SaaS systems, they should have APIs that are up 24/7, that are performant, and I don't even need this data grid we just brought in. So maybe we missed the boat there. Well, it couldn't have been any further from the truth. So the SaaS systems APIs were not 24/7. It's not to say they weren't down a lot, or that they were down a lot, I should say. It's just contractually, they were allowed to be down as much as 2 hours per night. We're a 24/7 business with 400 plus clubs operating 24/7. That did not work for us. So to mitigate that, we implemented this data flow where we still treat the HR system as our system of record for employees. We detect new hires, name changes, new jobs, terminations. We save that by way of our data services into the data grid, and all apps, Kids Club's just one of the apps, there's probably 15 to 20 other UIs or clients or apps that use employee data. We instead make all of our reads go to the data fabric, and that performs better, and it also makes it so if their APIs are down, we still have our club information. You might wonder why we have this HR database. That's a legacy thing that's in play because we have other databases, 3 or 4 over here, plus some data warehousing and reporting that queries that database. So we chose to implement this sort of cache aside pattern, cache, and also have the database backing the cache. So we reload cache from this database. So I think we can improve upon this situation. In the other slide, our data services has all the code and knowledge that we have a database, and it reads from the database, and then it updates the cache. But I think the cache can do that for us. So an improved solution that I'd like us to refactor to would be to use the grid to persist or do write through, or write behind, I'm not sure which, but write through makes sense to me to keep both of these two systems in sync. Write through means it's like a transaction. When it goes into the grid, it has to go into the database. Write behind means when it goes into the grid, if the database were down, the grid would asynchronously send it to the database. So it's not a transaction. I think we could go either way, but I chose to diagram write through because it made most sense to me. I think we can improve upon this situation even more. I said that the HR database was used by other systems, materialized views over database links, and reporting and whatnot. Eventually, when we migrate all of our legacy systems to new systems, it's my hope that we don't need this HR database anymore. And then we can take advantage of Apache Ignite's native persistence or GridGain's native persistence, where we don't have a database backing this anymore because we really don't need it. The other thing this gets us is it's taking about 30 minutes to do we eagerly cache all of our employees. It may not have been obvious in the diagram, but on a maintenance window, which we do once a month, it takes about 30 minutes to an hour to load all of our employee data, because we don't just load our 22,000 active employees, we have to load historical employees, and we have some turnover. So the native persistence, at least the documentation from GridGain says the cache will start up instantaneously. So that's something I'd like us to look at in the future. So we bring in a lead management system in the cloud, and we implement it in a CRM system. It's kind of synonymous if I say CRM or LMS or lead management system. They're all the same thing. So Craig thinks that was just a fluke. Surely we can create leads in this lead management system, and if we need to read leads, then we can get it from that lead management system as well. But it doesn't work out that way. Let me go back one slide. This create lead, notice I expected one call, sort of a business method to create a lead, taking in a state like California, but that's not really how this system worked. It was a very chatty API set they gave us. We needed to take, this is just one of the 3 examples, but take a state like CA, call their API, get the GUID for the state, so we could use the state GUID to create the lead. So it creates a very chatty UI. Plus, they didn't perform very well. Little disclaimer, they've rectified some of the issues with their APIs and performance, but at the time of implementation, these were taking 500 milliseconds or more. So our solution, you probably guessed, we use the data grid to cache. We eagerly, on startup of the data fabric or the data grid, we call the APIs for the lead management system saying, get me all 50 states and their GUIDs. We cache them in our data fabric. We do the same for the club team or the location GUID that we need. We do the same thing for the lead origin. A lead origin's like, are they a lead in the club or on the web? Did they download a 7-day pass? Those kinds of things. We store it in the cache. Now when you make a purchase, we don't chat back and forth 4 times to the CRM system with their APIs. Instead, we chat back and forth 4 times with a service we created backed by the in-memory data grid. And we'll show some timings on how fast that is. But first, an eye chart. Don't try to read this. It just shows some of the complication. I'm simplifying it. I said 3 calls, but we can see the ones I showed, a lead translation. Oh, I should have said this is an open source BPMN, or Business Process Management System. We're looking at a BPMN, Business Process Management Notation. And these are the actual steps our service does in order to create a lead, which is over here. So you can see we translate the lead origin, the club number. We didn't have a gender, but if we did, we'd be translating that to a GUID. The other thing is, there could be more. We could have had preferences. We'd have to do some translations and call the APIs here. And the other point is, if you were to purchase a membership online for yourself, that's one lead we're creating. But you could purchase a membership for yourself, your spouse, and your 3 kids, in which case we would be creating 5 leads looping through the same flow. So the problem of the slowness and the chattiness of their APIs, it exacerbates in certain flows and depending on certain use cases. This is dynaTrace, our automated performance management system. It puts agents on all the JVMs and it gives us timings of the service calls. So what we're looking at are the timings from the diagram I showed. Here's the create the lead. First it calls the CRM APIs and it says, does the lead exist? That takes 42 milliseconds. Then you can see the chattiness, but instead of going to CRM, we're going to our web service we wrote back by the data grid, and you can see that these are 3 to 5 milliseconds, so much 10 times faster than the CRM APIs. So it just shows some of the time savings we're seeing on one simple transaction. So the road wasn't all smooth. We had some marshaling issues. Essentially, we implemented pre-Ignite 1.5, and it did not have the grid gain binary marshaller. And our problem was we put our domain model objects like a customer or a member, their agreements, clubs, we wanted to put that in the cache. And it worked fine on startup when we had 3 nodes or 4 nodes. But if we tried to add a 5th node on the fly, the cache loader wasn't loading. There was an issue in the cache loader, so it wasn't loading those classes into the grid, and that 5th node would come up but not be ready for use. So we wrote our own marshaller. Don't do this. In Apache Ignite 1.5 or later, they have their own grid gain binary marshaller. So in the future, I'd like to see us move to that. One issue that we came up with that was kind of interesting, we started off with multicast. We had 4 nodes out there, and they're distributed, so they need to talk to each other. No one node's holding all the data. We set it up to do a backup where one node, if we lost one node, the other 3 remaining nodes would still have all the data they needed. What happened to us with multicast, it was due to our network issues, but periodically we would lose nodes. So imagine we have 4 nodes, we lose 3 can still talk to each other and 1 can't. The 3 that can't talk to each other start redistributing data, no problem there. They have all the data they need. The one on over here doesn't have all the data, but it's still up. Our load balancer, if it sent it to the JVM that had 3 or to the one of the 3 JVMs that were still talking to each other, we'd return every employee ID. Everything's fine. But 1 out of 4 times it would send it to the JVM that couldn't communicate with the other 3, we would start to see intermittent issues where it couldn't find an employee ID. We were scratching our head. We switched to TCP/IP to get around our network issues. I'm not necessarily suggesting you do that, but that's how we solved it. But this is a good lead-in. You're implementing a software solution, but don't just have your development team implement it and maybe set up some infrastructure and deploy it, because it's different than a regular system or our historical architecture. When you have a distributed system, you can have issues like we had with the intermittent node connectivity, but also you have other issues like what about cache validation? How do you know when the cache is fully loaded? You're going to need your operations team to understand how to do that. There is a Visor UI or a management console, I've heard it referred to. We implemented not on grid gain, so we haven't looked into that. In the future, we'd like to look into that, but we made use of command line scripts and APIs that we wrote to do things like interrogate the cache, refresh the cache if needed, and then, like I said, with this issue, we had to bring in other groups, the networking group and the infrastructure group. It sure would have been better if we involved them when we were before we were in production with an issue, instead of saying, hey, we have this new solution and there's a problem, you need to help. So, involve all your other teams. So future possibilities, we talked about the top two. In that HR employee data improved solution, we talked about putting the database below the grid or making the grid sort of a first-class citizen on top of the database so that our services don't have to understand both data stores. And then we improved upon it by saying, what if we don't need the database? Then don't even have a database, just use Ignite native persistence. Other ideas I'd like to explore, we have one vendor, a SaaS vendor, who on their API calls, they want us to pass in the primary key IDs. Instead of us making a call and them generating it and returning us the IDs, and if we need to store a cross-reference to our identifier for that particular thing, they want us to generate the unique IDs. Currently, we've implemented that with a MySQL auto increment field, but it's a nightly batch, and that it slows it down considerably. Ignite has an in-memory ID generation. I would like it to look into the ID generation in memory and see if we can speed up that batch time. And then the other thing we're trying to do, like I mentioned before, we have a maintenance window that we take our systems down once a month for about 10 to 12 hours. And I would like to see if we can keep up some of the systems that don't rely on databases, because we should be able, with the distributed nature of the grid, be able to replicate it across data centers such that if we take down data center 1 for a maintenance window, we should be able to serve at least read-only data requests from our DC2 data center. Now, it won't be just the data grid that we have to implement in both data centers. We'll have to implement other systems like our ESB and other higher level systems as well. But that's something where the grid is, I think, put us in a position to solve that problem, whereas if we were sitting on an Oracle database, we're never going to replicate that to DC2 just to stay up for 10 more hours. So we have another use case. We're getting real close to implementing or replacing our Oracle app system and moving to a SaaS subscription management system. It's kind of the lifeblood of our country because club subscriptions is basically what we do. So it's a pretty big project, but our concern is, what if the SaaS vendor's down and someone tries to make a purchase online? Are we okay if they're down and we can't make a purchase? The answer is, well, maybe, but we can do better with the grid. And not only that, the subscription management system, this SaaS vendor has API rate limits. We'll talk more about those in detail, but that means that if we call them too much, the system starts not working. So our proposed solution at this point is to, on every sale, write data, attempt to write it to the SaaS solution. If it's down, okay, that's probably fine. Write it through another subscription data services to the in-memory data grid. And then all apps, could be Kids Club I showed before, but could be the online portal, member services or customer service portal, all apps will read data from the data grid. And that will mean less calls to APIs to read data. So that will help us, or that will mean we won't hit our API rate limits. I kind of allude to it here, but the plan is, if we write here and you go into this app and you say, hey, what's my purchase history? We can give you something you bought 5 minutes ago from this data store, even if this arrow was red. When this arrow turns green, then we'll have to implement some retry capability and go ahead and find the data in the cache and persist it to the subscription management system. So I talked about API rate limits. I think I talked about all these use cases, but it kind of goes into the SaaS systems aren't nirvana, depending on your business. We're a 24/7 business. But there's a few reasons why a SaaS solution's APIs may not be nirvana. We talked about this one. Maybe they're down, they're not 24/7, or contractually they are allowed to be down and you need to protect your business. That was the HR example. They're not performant. Maybe they're just too slow. That was our initial what initially happened in our lead management or CRM system. And then in addition to that, that same system had a lot of chattiness or CRUD-based APIs instead of business facades to create a lead. So that could be another thing you'll find. API rate limits, we just talked about it, but the two we've seen is concurrency, meaning the amount of processes you haven't going on at any given time could put you past the limit. And this particular SaaS implementation, it's pretty bad. If you go over 40, they're gonna lock you out for 2 minutes. And we're trying to make sales, and we're doing a lot of reads against that subscription management system, and they lock us out for 2 minutes. That's bad. So I'm trying to point out why implementing those reads through the data grid is very important to us, because we can't hit this limit, or we call it the money spigot. The money spigot stops. We don't make sales. And the other one we've seen are just calls per minute. Slightly different than concurrency, but a certain number of calls per minute and you'll start failing. Another reason to not call their APIs to do reads and maybe consider storing it in an in-memory data grid. So whereas I thought SaaS solutions would eliminate the need for an in-memory caching solution, hope you've seen quite the opposite is true. Every SaaS solution or vendor solution we've implemented, we've ended up utilizing the in-memory data grid. So what have we seen so far? Historical architecture and some limitations. We didn't have a distributed cache in place. We solved it with Hazelcast distributed cache. And then we moved on to some issues, intermittent node connectivity. I can't stress enough to, if this is new to you, to bring in your other groups, your networking and infrastructure and operations group before you put the grid in production. And we talked a little bit about how it might be used in the future, basically moving it up and making it more of a first-class citizen such that we don't have a database backing it. Our services don't even know if there's a database, and our services rely upon the grid, especially for reads, even more than they rely on the read APIs from a vendor system. I want to thank the Target presenters from 2016. I know they're not here, maybe they'll watch this, but I was out here in the audience just like you, and they were presenting, and I went home, and about 2 months later I said, 24-Hour Fitness has a story to tell. I can come up here and present this to you, but maybe next year you'll be up here presenting, and I'll be out there watching you. Shameless plug for 24-Hour Fitness. You saw we have BPMN, we have a rules engine, we have event or message-driven architecture with ActiveMQ. We are doing a lot of SaaS integrations. We have 2 in-memory solutions, and we're in North County, San Diego. Carlsbad to be specific. And then I couldn't end this without thanking all my 24-Hour Fitness colleagues who helped me. I did many practice runs. They helped me with the content, error checks, all that good stuff. So thank you. I did want to say, my email address is here. If you send me emails, if you have any detailed questions on how we implemented these kinds of integration specifics, send me an email, and we have like 30 plus people on the team who can help me and get some detailed information if that helps you guys. And then I did create some of the stuff I talked about is on this references and further reading chart. So if anything was like, what did that mean? Hopefully there's a link there, or you can email me. Any questions?
At the beginning of your presentation, you mentioned Hazelcast as the implementation of distributed data grid. And right in the next slide, grid gain and ignite were in the picture.
So I think the question is why didn't we just stay with Hazelcast? Why did we switch or go have 2 solutions in play? It was about 3 years ago, and at the time when we compared Ignite to Hazelcast had more features. Although it's interesting, we haven't really used many of them yet, but we hope to in the future. Now, a disclaimer, I have not done any research recently to say what Hazelcast's capabilities are. So if you're looking between the 2, I suggest you evaluate both of them. The question was, what version of Ignite are we currently in production? We started with a pre-1.5 Ignite a while ago, and we just upgraded this summer in June, and now we're on GridGain 7.8.4. And then we have on the roadmap to upgrade to whatever the latest version is at that time, sometime this year, because there are a couple features. I believe maybe that native persistence was one, if I'm not mistaken, where I don't think we have that in our version. So if we want that, we're going to have to consider upgrading our grid. Anybody else? I thought I saw a hand over here somewhere. Another one?
Sorry for that. Have you, I remember you mentioned about your maintenance reviews and stuff. Have you tried the zero downtime upgrade?
We have not tried that, because I guess for us, since we're down once a month, we have an opportunity to do it, so we have not looked into it.
To upgrade the software, you roll out the next version, you do it during the official maintenance review.
Sometimes we'll set up separate tiers. We'll bring them up, make sure the cache is loaded, make sure they're functional before pointing our load balancer to them. So that's something we can do to kind of set them up, sort of have an A-B going, with A being what's been running and B being the upgraded. And once we like what we have, we can seamlessly transition.
I'm particularly interested in the question of coexistence of different versions of your objects.
Yeah, I glossed over it a little bit. Our current it's interesting, there was a presentation about the digital twin in here before this and storing more objects in there. The implementation that we chose, due to some of those marshaling issues we had, we wrote our own custom marshaller, and we marshal into native Java objects at this point. So that's, I was just talking with my fellow architect, how come we can't do indexing? And I haven't gotten to the bottom of it, but I'm afraid maybe that implementation decision has affected our ability to index things in the cache. Not that we need to yet, but we want to put more data in the cache. So when I get back, I'm going to try to figure out. We want to get rid of our custom marshaller, and we want all the features that the grid has to offer, and I think getting rid of our custom marshaller is the way to go.
Are you running your instance in the cloud?
We are running everything on-prem, even our ESB, and then we're just hitting the SaaS solutions. Mostly, I shouldn't say mostly, everything we have that does our caching and our integration and our event-driven architecture is all on-prem, and then we have SaaS solutions that are out in the cloud that we integrate with.
Sorry.
Go ahead.
Anyone? When you design, when you architect your data model, basically the classes that will go green at night. Basically, do you go with a large number of small objects, or you prefer to go with like large objects with small numbers?
That's a good question. I'll get your email. I can get you an answer to that. I don't personally haven't made that decision yet, but I will get involved with that, because like I said, we're not really, we're storing, we have our own marshaller and we're doing things differently. And also, as we replace that Oracle ERP with what I call members and contracts, or customers and contracts, we are going to have to revise our entire data model. And part of that is because we're trying to do things. Right now, our notion of a customer is somebody who has access to our club. It will start to be somebody who maybe has an online subscription only and doesn't have access to our club. So we have a lot of data model things to consider. In the previous presentation, I forgot the digital twin. I don't know if you were in that, but if you weren't, you might be interested in that one. And that yeah, he might have some ideas on that. But when I saw that, that reminded me of the Eric Evans book, The Domain-Driven Design, because he kept talking about you need a good object model because it helps things. And I was like, I agree with that. It helps to have the right object model because it makes everything make sense. It's easy to expand upon.
How do you plan on seeding your GridGain cache if you don't have a database?
I'm sorry, could you repeat that?
How do you plan on seeding your GridGain cache if you don't have a database? You don't have
The question was, how do we plan on seeding the grid gain cache if we don't have a database? Let me back up a little. I could do this. Yeah, the native persistence will handle that. And in this example, the HR example is very similar, and we have actually implemented that. We're basically treating this, or the HR system, if you will, as the system of record, and all event detection and changes happen in this system, and one way or another, we have to detect that. SaaS solutions have various ways of doing that. Sometimes it's polling a cube, sometimes it's webhooks. Ideally, it'd be event-driven architecture where they'd put an event on a queue and we'd listen to it. But one way or another, we have to detect changes in this system and make this system so. In other words, make it correct. And it's kind of an eventual consistency, but we don't control this system. It's somebody else's system. They built it, and for reasons other than integration, we've chosen that solution. So it may not be the easiest solution to integrate with in some cases, but it makes the most business sense for 24-hour fitness. Anybody else? Could you repeat that? Yeah, the question or the statement was, do we try to go to the SaaS solution first and then to the cache? And actually, I have two answers to that. If we're creating on a purchase, we're going to want to get that in the subscription management system. But if we're doing a read, we trust our change detection and that we've made the grid correct, because on every purchase we put it in there, and we trust the grid for reads. It's kind of eventual consistency. If this is down, eventually we'll get those changes and make it right. But this is the best we can do, and we can't always do the reads against this, because the slide I showed with the concurrency rate limits was for this subscription management system. If we did all of our reads, we have a bunch of apps, and we have a website, and we got a mobile app, and we got 450 clubs, we would hit that rate limit and shut ourselves down for 2 minutes. So we can't accept that. Does that answer your question? We could, yeah. We certainly could. It's not really depicted here. Well, it might be because I put A and B, but this could be an asynchronous call. We could put a message on our ActiveMQ that reads it, and it's a separate process from this one. So there's a lot of implementation decisions we could make on that. But yeah, you're correct. All right, your last one. No, I'm just kidding. Yeah, the question was, when we load our cache, do we use, did you say HQL? Or do we just use the facade? Well, I'll answer it. How do we load our cache, essentially? It's kind of described in here. I think in the future we might do something different, but everything we've done now is sort of a cache aside pattern, where what I would say we've done is we've probably created too much code that developers have to write, and rewrote all that code in our data services to understand how to query the database and how to load the cache. And so, for example, on this one, we have an API that you can call to load a single employee ID. If for some reason, I don't know, it got out of sync and some employee couldn't get into an app, and we needed them to do their job. That's kind of the operations part I was talking about. That happens, or if they get a call, we need to get them in here. It probably means we have a bug in some of our other part of our system, but nonetheless, we have ways to get it in here. But we issue on a maintenance window just a load all to this service, and it'll query all the data from this database and then put it into the cache. So we're actually having troubles with this, and when I created these slides, the improved solutions, I'm kind of trying to drive to these improved solutions where we can speed it up and maybe not take an hour after a maintenance window, because that's an hour where people are up at 2 in the morning waiting an hour, and they can't smoke test any applications. All they can do is wait for the cache to load. We might do read-through or lazy loading, but historically we've always had all of our employees in the cache.
Can you talk a little bit about how you guys check to make sure your change detection data actually got down to the cache?
The question was, how do we make sure our change detection actually got the data into the cache? Yeah, that's sort of, so if we detected, this particular implementation, they have APIs, we call it sort of polling that we're doing, and they have a queue. It's kind of a service-based queue, I guess you'd say. But we call it, and then we call this and save it to the grid. And I think your question is, what if something goes wrong in here? We have dynaTrace. I showed timings, but dynaTrace can also be set up with alerting when it detects errors that come out of these JVMs. That's one way. We also have historical solutions that if we log something to the server log, they'll be scanning those logs and detecting that condition. But in actuality, it comes down to, during the implementation, for a development team to work with our operations group to say, if you see even one of these errors in the log trying to update an employee, you need to alert this team. If we don't do that, they don't typically trigger on one single data error. So that can cause problems. That can also cause, maybe that employee is having problems logging into their systems or using their systems. They call our help desk or customer service, and then our customer service has ways to load that employee via an API into the cache. So it's, like I said, it kind of points out an error in our process, but we give the people who have to take the phone call a way to let our employees get in and use the applications, and then we try to figure out what went wrong and how can we do continuous improvement and make this a little bit more reliable. But yeah, it's a good question. It does take some work. It's not trivial. Any other questions? Reception time? Thank you very much. I appreciate it.